Module two's guided notes are going to go fairly quickly because most of Module 2 is application. So your problem solving is going to be a larger portion of your notes. So some equations, you're going to have that delta S naught of the reaction is going to be equal to the sum of the delta S naught of formation of the products minus the sum of the delta S naught of formation of the reactants. So that's a whole lot of words and a whole lot of symbols, but once you get into these, once you get to working these, it goes very quickly. So the delta S and the delta G naught of each the products, and I can spell reactions, the products and the reactants, those are going to be tabulated. And once you do a couple of these, it's no big deal. So we're just going to write these down in case you need them. A couple of things you're going to need to remember. You're going to need to remember how to balance equations because you need those coefficients. Remember, those stoichiometric coefficients found in the balanced chemical equations are going to be used many times, including in this module. You will also need to know that delta G is going to be equal to delta H minus T delta S. So you may want to review H, which is entropy, or excuse me, enthalpy. S is entropy. Enthalpy, which is also tabulated on the same thermodynamic table that you will be using to get your S and your G. There's also another equation, G equals negative RT, L, and Q. So we go over Q in Module 3, so you're going to see this one again. I'm writing it down just to be thorough, but I don't think you're going to need that one here. So you may want to write down the units of each of these variables just so that you can keep everything together. So some definitions of things you're going to need. You will need to know the definition of entropy. You will need to know the definition of Gibbs free energy. And the difference between, say, S naught, SF, and delta S. So what are those differences? What do those mean? And what does it mean when the delta S is greater than 0? What does it mean when delta S equals 0 or delta S is less than 0? Similarly for G, what does it mean for each of these states? And also remember that there are 1,000 joules in 1 kilojoule. So that should be what you need to remember for Module 2. Like I said, there's a lot of application. There should be a lot of problem solving for this module. Let me know if you have any questions.